will be recorded, so that we can later share this on the website. Today, I think we have a pretty packed schedule. First, we are very happy to have Lalit Suresh from VMware to come over to talk about his declarative resource class management work. Scheduler actually is the core of class management, and it's also a key component in the Centaurus. His work is very different, is very innovative than the current way we build the schedule. So we're very happy to have this talk. And the second is we will discuss whether we include the Polaris Cloud into Centaurus repo. This work is a joint work between QA and FishWay. The last one, I think Annie and Rupa will give some update on the community outreach. So without further ado, let's go to the first one.
Just quickly, before Lalit starts, let me just give a background. So just to kind of, so Lalit is from VMware Research Lab. So what happened was, just to set the background, Lalit actually reached out to us, and our team did similar kind of work, the scheduler work, scheduler called Firmament. So it was also a declarative way of doing scheduling as well. So while we were talking about it, and then I brought up Centaurus, and then as just a brief discussion I had with Lalit, this sounded really very interesting. So the Firmament was a declarative scheduler as well, but the programming model was very, very cumbersome actually. So I think so the more I look at it, I went through the paper as well. This looks pretty interesting actually. This whole SQL-based, without writing any code. If you're familiar with the Kubernetes, you have to write tons and tons of code, the scheduling code, so I think so that's what the background is. So I'll let you, Lalit, you want to go ahead?
Yeah.
Oh, just one sentence.
Okay.
Deepak, do we still have people on Firmament or on Poseidon to maintain it?
So no, so that's unfortunate actually. So we haven't had any activity on the repo. So we've been asked by the CNCF guys to retire the project actually.
I see.
So if you folks think, if there's I mean, we don't have the developers anymore, to work on that project. But if you think you're somebody from TikTok or somebody else would be interested, it'd be good to have that project active actually. So
okay, yeah, I will see, because we also have a group working on scheduling.
Oh yeah, that'll be really great, because they've been pinging me if we can retire, because there hasn't been any activity for the past 1.5 years actually on that project.
If we have to retire from CNCF, we probably can host this project in Centaurus, so we can have some further activity there.
Yeah, definitely. It's a good idea. Yeah.
Okay.
Good.
Yeah, hopefully I can convince you to start building your new schedulers with this tool instead. All right, so the problem statement here is basically that no matter what you're running in your data centers, right, whether it's virtual machines or pods or containers, lambdas, what have you, you're going to solve the same kinds of problems over and over again. You'll basically have tons of these cluster managers involved, and their job is basically to take these workloads, assign them, resources, or assign them to physical or virtual machines or whatever, and configure the underlying infrastructure to run smoothly, right? And across all of these problems, across all of these scenarios, you'll find that, tackling these problems over and over again is extremely hard to get right. And the cluster management logic is very hard to build from scratch. And yet we do over and over again in the industry. And in this talk, I'm going to show you a very different way of approaching this problem, where instead of writing code by hand to do things like scheduling, you basically specify what you want your cluster management logic to look like using a high-level declarative language like SQL, right? In some sense, you say, I want my state to look a certain way, and how you get there is handled entirely by our framework, right? So I'm preaching to the choir here, right? Like you guys have tried to build a public cloud platform, and you've looked at things like the vanilla Kubernetes scheduler, and you've seen just how hard it is to get right. So in something like the Kubernetes scheduler, the problem is you assign pods to nodes, and these pods come configured with all kinds of requirements, right? You have resource requirements, affinities, anti-affinities, and whatnot. It's like 30 different hard and soft constraints that you have. Now, the scheduler's job is to basically assign pods to nodes such that all these hard and soft constraints are satisfied, and you find some kind of high quality placements, basically. And this is the algorithmic problem involved here is it's a combinatorial optimization problem. It's NP hard in the general case. There's no silver bullet here, right? So you can imagine that writing code to solve this problem is going to be quite hard as well, right? So if we peek under the covers to look at how systems like the Kubernetes scheduler are built today, and this is just one example out of many, right? Like it doesn't even matter that it's a Kubernetes scheduler. It's the same problem, whether it's VMware's DRS, whether it is whatever you have to do in OpenStack. Any scheduling problem will have this kind of challenge. But if you look at how these systems are built today, you'll find that it's basically a collection of these purpose-built best effort heuristics, like a web of them. And you basically have to get this combination of them to work a certain way to satisfy all these constraints. And that gets kind of hairy. So in Kubernetes in particular, I won't go into all the details, but you basically start off with initial placement. The scheduler it takes in one pod from a priority queue, and then it has to look at all the nodes. So the logic executes one node at a time. So it's always comparing one pod and one node to see whether it can satisfy hard constraints, a so-called filter pass. And then it has to do a so-called scoring pass, which evaluates soft constraints and assigns a score to each node, right? So all these policies, like in Kubernetes, they call it predicates and priorities. I'll call it hard and soft constraints. But all these hard and soft constraints beyond the simplest cases, right? The moment you have some kind of global reasoning, like interpod, affinity, anti-affinity, you'll find that it's very hard to write code for this. You're basically having to write code that makes a local decision about one pod and one node. And you want those decisions to be consistent with some kind of global property you're trying to maintain. So what ends up happening is you start piling on all these ad hoc data structures, your caches, your indexes, and so on to efficiently implement this logic. And the moment you want to add some new kind of policy, this starts to break, right? Or you want to change the policy. Like if you want to make interpod affinity work at the level of the number of pods per node, suddenly a lot of the existing optimizations break. So this starts to get very fragile. And the worst part is that it's not even the full story, right? Like once initial placement fails, you have to jump to preemption, which is again, even more heuristics to determine which are low priority pods, how do I find them, how do I remove them, and so on, right? And you have to again reevaluate all these constraints over and over again. Now this is just a Kubernetes scheduler, right? What about if you wanted to do batch scheduling? So everything I've described here so far is for one pod and one node at a time. So now in the Kubernetes ecosystem, you have an entirely different scheduler to just do batch scheduling, the Volcano scheduler, right? And even that's not it either, right? Like there's still more. There's still descheduling, right? Like which is a job you run to decide which pods I want to reap from a cluster to free up capacity according to, again, certain rules. Now, the thing is, all of these four things I've described here are actually the same algorithmic problem, right? In one case, you assign pods. In another case, you remove pods and allow some new assignments. In some case, in some cases, you're assigning groups of pods. They're all actually the same problem with slightly different constraints. And yet there are four completely different blobs of code to do this in the ecosystem. And they're kind of duplicating the same effort, right? And if you now extend this to even things that are not Kubernetes, like you get an even longer list of wheel reinvention, I would say. Right. So in the aggregate, what we observed is that this pattern of building, this kind of hard combinatorial optimization engines to do scheduling, policy-based load balancing, etc., runs into a lot of problems. First of all, it's hard to make them scale and perform well, especially as the policies and constraints get more challenging. And then they usually sacrifice decision quality to scale, right? They use some approximation. They basically sample the set of nodes, things like that. So forget optimal solutions. They might not even find solutions sometimes because they don't cover the solution space systematically. And lastly, the extensibility thing is hardly alien to you guys. It's hard to add new policies to these systems. And second, like adding new features, like completely changing the scheduling game to, for example, making it multi-data center aware or something like this, right? Like when you start to add like new dimensions to the problem, suddenly a lot of this code has to be redone, which gets pretty nasty. So with no further ado, I'll describe how our solution works. So it's called DCM, a Declarative Cluster Manager. To go back to our running example of the Kubernetes scheduler, to do the same thing with DCM, what you would do is you would first represent your cluster state in a relational database, right? So this does not need to be this does not need to be something full-fledged like MySQL or Postgres. It can also be an in-memory embedded SQL database that is just a cache of some other data store. As long as you can sort of query it relationally over something like JDBC, you're good, right? Doesn't matter where that database is. But you basically have a relational database with the schema representing your cluster state. So now you have tables of your pods, your nodes, and umpteen other metadata that you might have for your scheduler. So in our Kubernetes scheduler implementation, we had 28 different tables representing all the metadata that's relevant in Kubernetes for scheduling. Now, against this cluster state, what you do is you describe all your policies and constraints as constraints in SQL. I'll show you how that looks like in a moment, but you're basically writing queries that specify some conditions that have to hold true for the state, right? You can write both hard and soft constraints in this mode. But the cool thing is, once you have this declarative specification of what your state is in the schema and what the constraints are in SQL, it turns out that there's enough information for our engine TCM to basically do everything that you were writing these ad hoc heuristics for before, right? And at runtime, what DCM will do is it'll pull in only what the state it needs from the database. It'll efficiently encode it into an optimization problem that it then uses in off-the-shelf state-of-the-art constraint solver to solve. It's one from Google. They use it in production, so it's good enough for others, I would imagine, right? And then you basically wire the results back to the calling code. And you can use this mechanism to do all kinds of cluster management tasks that involve this optimization flavor.
Hey, quick question. So you mentioned Google uses that the constraint optimization algorithm. Do they use that as part of Borg, or do you know?
I don't know if they use it in Borg, but it's certainly used for other kinds of problems at Google. It's called Google OR tools, and that's they have a dedicated team to build. The guys building that stuff are sort of kind of legendary in the constraint optimization world. And they basically use that thing for everything from routing to all kinds of, logistical problems, etc. So I don't have a lot of insight into how specifics at Google, but yeah.
This is kind of interesting though, because I thought Google guys were very against the SQL stuff. Now they're transitioning more towards SQL. In any way,
so the constraint solver has nothing to do with SQL. The bridging is done by us in DCM.
Oh, I see.
Yeah.
I see. Okay.
Yeah, good. Good clarification. Thanks for asking that. All right, so now again, this is all a bit up in the air. I'll show you specifics of how this programming model looks like next, right? But before that, like some more, wins, just to show that this is something we're building seriously, right? We've actually tried this out in several use cases, not just a Kubernetes scheduler, but also like a VM load balancing tool in the context of a VMware use case, as well as a distributed transactional data store, the core food database. And across these cases, we can show you some wins. Basically, you'll see more details in the paper, but we are actually faster than the baseline Kubernetes scheduler, at least at 500 node scales where we've tested it. And keep in mind that the default scheduler in Kubernetes is looking at half the nodes in the cluster per decision. DCM is looking at all of them. And since the publication of the paper, we've gotten like roughly 2 times faster compared to where DCM is. And over here, we are already like, 2x faster than the baseline scheduler and bringing up pods end to end. So you can throw in a database and a constraint solver and we're still faster than very hand optimized Go code that the Kubernetes scheduler has. And then of course, like these other parts of our design translate into things like better decision quality, which means, by using a constraint solver, we get better load balancing, faster preemption, things like that, right? And for extensibility, like adding new kinds of policies to the systems we've built is usually a matter of adding less than 20 lines of SQL. And even like very non-trivial feature changes, making a Kubernetes scheduler, for example, not just reason about pods, but also VMs that are running in the same, like VMs were CRDs basically in VMware's Kubernetes distribution, and reasoning about them in a unified way is just, few changes to the schema and a couple of constraints that should apply to VMs, but not pods. So it's quite easy to do it once everything is specified declaratively.
Is that similar to the KubeVirt?
If I understand correctly, KubeVirt was for, that's a data plane consideration, right? Like KubeVirt was for making VMs look like pods and running them. That's what KubeVirt is, right? But this was not done in the context of KubeVirt. Yeah.
In KubeVirt, the VM are also modeled as CRD, a new object side to side with them. So I'm just trying to see if the VM situation in VMware is similar to.
I believe they do it with the CRD as well.
Okay. So it's It's the kind of side by side with the pod object.
Yeah, exactly. Yeah. So, and it has its own controller and things like that. That's what I understand.
Oh,
so,
they have their own controllers.
Yeah.
I see.
So, okay, so that's the pitch. Let's get into specifics, right? So the way you approach, using DCM in any use case is to first represent your cluster state with some schema. So it'll look different from use case to use case, but for Kubernetes, it's obviously going to be like tables of pods. You'll have tables of nodes. Pods have to be assigned to nodes. So there will be a node column in the pods table. There'll be a foreign key relationship. That's like the basic SQL stuff that you have to do, right? But now, because you want DCM to figure out how to assign these pods to nodes for us, we're going to tag the node column as being a variable column. All right. So what this tells DCM is it look at the schema, it knows immediately that because of that foreign key relationship, that the cells here can only draw values from this set here, right? It knows what possible assignments are. Now, to make this primitive useful, you have to bound the set of choices by writing constraints. And the way you write constraints in DCM is pretty straightforward. Let's take the simplest possible constraint here, right? Don't assign pods to nodes that report to be under high memory overload, right? And so the way you write constraints in DCM, this syntax has changed a little bit. Like it's now called create constraint. You'll find that when you look at the GitHub repo, but you basically specify hard constraints as some selection of rows, and then you specify some predicate that should hold true for each of those rows, right? Pretty straightforward. So you can basically write in this example, select stuff from pods, all your pods, and you check, this is the hard constraint, that pods.node is always in some set of nodes, right? Here I can do some kind of filtering if you want. Now, of course, in practice, this will get more complicated, but you have the full arsenal of SQL's expressiveness available to you. You can do joins, you can do aggregates, you can do group bys, you can do correlated subqueries, you can do arrays. There's a lot of, and we also give you a lot of custom aggregate functions to express your constraints. Soft constraints are the same. You basically write a view where now you give some expression that you have to maximize. So it's similar to hard constraints, but instead of check, you basically write maximize and you give an expression. So you can do this, you can use this to do things like load balancing. For example, you can compute some join that calculates the spare memory capacity per node. Now this itself is a variable because the value of that will depend on the assignment of pods to nodes, but you don't need to take care of that. You declare it and DCM will deal with all the nitty-gritties for you. But then you can say, I want to maximize the minimum spare capacity per node, and that will cause DCM to find allocations that spread out your pods. Right, so the programming model is you express all your policies, like you express your cluster state with SQL in some schema, and then you write policies in SQL using everything from joins, subqueries, whatever you have in SQL, right? So you have a lot of expressive power here. And the concrete programming model, the way it looked like when you're actually writing Java code, is that you instantiate these little things called models. And a model is parameterized by a connection to a database from which DCM will fetch the schema and the list of constraints, which are strings in SQL, one per constraint, right? And from this, basically DCM will, instantiate a model. It'll do some code generation, compiling under the covers, and it'll give you back this model. And you can think of this model as encapsulating basically one optimization problem you're trying to solve, say initial placement or preemption or batch scheduling, whatever, right? And then at runtime, every time you call model.solve, what happens is DCM will pull in all the state it needs from these tables, and it will do so. It'll pull in all the tables, and then it'll use a constraint solver, and it'll output basically the same tables, but with values assigned to the variable columns. Okay, so now this is how you basically get your scheduling decisions. And if you don't find a solution, basically DCM will give you an exception. It'll tell you it was unsatisfiable, and it'll tell you why. It'll give you a list of constraints that were unsatisfied. And we're also adding support to not only give you the set of constraints that were unsatisfied, but the set of rows that led, the set of rows from the tables that led to the unsat, right? So you can use this to basically get explanations of why you got a failure. Right, so
question here.
Yeah, go ahead. Yeah.
Go ahead, Yunmin. Yeah, go ahead.
Okay, sorry, Deepak. Just quick clarification. So is the DCM at the runtime for every pod to be scheduled need to be access to the database, or everything would be determined inside the DCM program?
It basically, so the working model is like it pulls in what it needs over JDBC, right? And so you do this for a batch of pods at a time. That's usually the expected model, right? So it runs, so basically all your constraints are accessing tables, right? So DCM knows the set of tables and views you need to access from the database. And once per, like every time you call model.solve, it'll do a series of SQL queries to get everything it needs. And then it outputs a decision. So that's the model, but you do it for a batch of things.
I see.
So bulk scheduling as opposed to part at a time scheduling.
Exactly.
So that means all the calculation to make the assignment is done at the DB engine.
Yes.
Yes and no. You can. I'll tell you how that looks like. That's actually a very sharp question. So I'll give you some more insight into how the split between what you do in the database and what you do in the solver will look like.
A quick question. You have any question? Are there further question?
No, this is basically the first question I have is basically I want to get very like straight answer to see all the scheduling decision, which is assignment was done, all the calculation was done at the database engine, or the DCM binary had logic inside it to decide it.
The DCM solver will make the final call on the assignments. That's where the constraint solving is happening. But you can do a lot of the pre-computation to do that in the database. For example, if you want to compute affinities and anti-affinities, right? Like if you want to have that kind of policy, you can basically compute from the database a table that says this pod should be repelled by these nodes. Like you can do that type of pre-compute in the database, and that becomes an input to DCM when it's doing the constraint solving.
Yes. So the follow-up question for this first one, thanks for clarifying that, would be like right now, at least in Kubernetes, all the data was stored in the etcd, right, from EPS server.
Yeah.
And the node can come and go, and node can fail, new node can be added.
Yes.
So how do you synchronize this information with your database?
It's the same as anything you do in Kubernetes. I'll show you. Give me 2 slides.
Okay, good. Thank you.
Yeah,
I'll wait for that.
Yeah, I'll show you exactly what the difference will look like between the base, like the Kubernetes scheduler today versus one done with DCM. Right. So
one question I have. The solver. Yeah. So I want to go back to the Firmament solver. We had solver there as well. It was a graph solver, and it was pretty dumb, basically. So dumb in the sense you have nodes and you have arcs, and it you go from left to right. Okay. So you have to pretty much define all the nodes and arcs and upfront the whole structure, XOR or AND and all that kind of thing. It's a pretty complex program.
Yeah.
So in your case, you're saying their complex optimization engine algorithm is not SQL based. How much of an effort was that? Because you said you bridged that gap between SQL on one side and the optimizer and solver on the other side.
This is basically the majority of the effort, like making sure that we can. So because the literal translation of SQL to what you pass to a constraint solver will simply not scale. I'll show you some quick data on this, like just a teaser, just to show you that you have to, like, you need the smarts that the compiler has under the covers. But it works pretty well now, but because we already put in that effort.
Yeah, because that was the major problem we saw in Firmament, actually. Yeah. Because you have to pretty much stage everything, as far as the graph. And then the solver is pretty dumb. It just goes from node to node to node. And
exactly. So the thing is, like, compared to the Firmament, what it is, it's actually not a solver in the sense that the constraint satisfaction community would call something a solver. Like, that's really just an algorithm, and you're kind of coercing everything to work on that algorithm.
Yes.
The solver here is like a true constraint solver based on some very fancy technology. Like, it's really a very different league of its own, I would say.
This is very interesting, actually. So this is the main difference between, that's why the programming model in Firmament is not that friendly, basically.
Exactly. Yeah, it's very hostile to expressing anything complex because you have to worry about the graph. Here, you kind of really declare what you want to the solver, but even in that declaration, there are a lot of subtleties involved, which we take care of for you.
Yeah, I'm also interested in this part. On the GitHub homepage, I see it says now it supports 2 different solver backends.
Yeah.
So do you observe any significant performance or feature difference among these 2?
Indeed. So the first thing we were using was this thing called MiniZync, which was easy for us to get started, like get the project started, but it was simply not like it's extremely slow. It's a high-level modeling language, which will then compile down to something that talks to different solvers. And that thing was just extreme. Like I couldn't even get it to work for a 30 node cluster. Like it was really that slow.
I see.
And so basically I had to implement everything that thing does in the sense of like, I'm generating a program that is crafted to do optimization for the problem you have. That's basically what I generate under the covers. So
you eventually switch to the Google one.
Yeah, exactly.
Okay, thank you.
So we were first using the Google one through MiniZync, which was too slow. So now I basically shortcut all of that and go straight to the Google solver, and it's much faster, right?
Okay, thank you. Nice.
So I just want to be cognizant of time. Deepak,
I think you can go for another 10 minutes.
Okay, sounds good.
Annie, how long do you think you and Rupal need?
Just 5 minutes, not long.
Okay.
If that's the case, Deepak, I guess we probably can have a little more time. We can.
Yeah. You know, why don't you go ahead, take whatever time you, and then I'll skip my topic actually if I need to.
Okay.
Okay. Then you probably have like 45 to 50 minutes.
Because what Annie is going to cover is very important. We should cover that. You know, if there's no time, I can move my slot to the next one.
Okay.
Okay. Thank you, Deepak.
Yeah, and also maybe do you think we could have I can talk like before the last one, so you guys can take as long as you want. How is that?
Oh, no, don't worry about it, Annie. You're going to go first. So I may not even do mine, actually. So
okay, all right. Okay, no worries.
There's only yours, and Deepak's the one after this.
Okay.
Yeah, keep going, Lalit.
Yeah. So back to the programming model, right? So I mentioned you instantiate these little models. And the idea is like you talk to the same database and the same schema, but you instantiate different models that cover different kinds of cluster management tasks that can operate at different time scales. So for example, you can have one for initial placement, which really only looks at the set of pending pods. And it does a lot of pre-computing in the database to compute how those pods should relate to other things in the cluster, right? But you can only, you can give a fairly small problem to the solver to deal with. And if that fails, you can basically fall back to a preemption model that basically brings in even more pods to look at in the system. And in the preemption model, you can have a few additional constraints that say, what pods are allowed to be, kicked out, what are not allowed to be kicked out, and so on. And similarly, descheduling is almost the same as preemption, but you're not assigning anything new. You're only removing things from the cluster to improve some kind of utility, right? And now one thing I want to mention, like I said before, is that the part that DCM will take care of you, and I'm happy to go into any level of detail you want on this, right? But basically, we use a thing called a CP solver. That's what this Google OR tools is. And the performance of a solver is quite sensitive to how you present problems to it, right? And this is entirely the smarts that have to go into the compiler to get this working. But basically, it involves making sure that once we are translating from SQL to the constraint solver, we basically remove we basically reduce to the extent possible the number of variables we are presenting to the solver as well as the number of constraints, right? So we basically have to encode this quite carefully. And the second is this thing called global constraint, which is something peculiar to CP solvers, where there are some patterns of constraints for which the solvers implement specialized algorithms to solve. One classical example is the so-called all different. You have 10 variables and you want all of them to be a different value. You can either encode it pairwise by doing a nested for loop and saying, each pair should not be equal to one another, which basically gives you a quadratic number of constraints, right? But you could also then instead say, all different, all these variables. All different is a well-known global constraint. And under the covers, now you've signaled very clearly to the constraint solver what your objective there is, and it knows how to use a specialized algorithm to resolve those constraints. And all different constraints are quite handy when you're dealing with things like anti-affinities, for example. But the the cool thing I'll show you is just how big of a difference these things make. Right?
Just one, Lalit. So all the group by, for, let's say if I'm doing a pod affinity or I'm doing gang scheduling and all that kind of stuff.
Yeah.
So all that magic of doing group by in a database, that happens before you send information to the solver, or when does that happen?
Happens at both levels. So there's like I said, I'll show you in a moment how this will look like, but you can do a lot of that pre-computing in the database. For example, computing the spare capacity per node. Kubernetes doesn't tell you that off the API. Like for example, how many, so when you assign pods to nodes, the pods might have, CPU requests, limits and these things, right? How much spare capacity you have on the nodes is not something Kubernetes will tell you. You have to do the join yourself. The Kubernetes scheduler does this today as well. So that kind of joins and all those expensive aggregations, you can do a lot of that in the database. But even the way the constraints are specified, for example, for gang scheduling, you would need to say, you would need a group by say groups of pods and say either all of them are assigned or none of them are assigned. That group by we have to still do at our end. Right, because it's needed for the constraint specification. Yeah. So anything to do with the constraint evaluation is done on the DCM side, basically. Right. So here's a simple benchmark task of taking 50 tasks and assigning it to 1,000 workers. And we basically have this, some of the constraints on the Kubernetes scheduler. And a literal translation of SQL to constraints as opposed to the OR tool solver will take 25 seconds, which is so useless that nobody will come close to it, right? Close to such a tool. But with these optimizations we have, we've been able to bring it down to as slow as 85 milliseconds. Again, this number is very old. It's actually closer to 16 milliseconds by now, right? But the things that the DCM compiler does under the covers is quite necessary for performance. So now the question that we got earlier, how does it look like when you're actually building something for real, right? So the use case for the Kubernetes scheduler will look like this. So you still have to do what the baseline scheduler does in terms of subscribing to events from the Kubernetes API, right? So you have informers subscribing to, notifications about your pods, your nodes, and other data types that are relevant to scheduling, like, for example, the disruption budgets, all of those things, right? Now, the differences between doing it without DCM, vanilla scheduler, and with DCM are like this. The vanilla scheduler will have a lot of state described in custom data structures. In DCM, a lot of this we basically manage in the scheduler itself. So we don't use a database sitting away from the scheduler. We use an embedded in-memory SQL database called H2. We are now replacing this with a different thing to do incremental computation, but we can talk about that after.
So all the node state, the cluster state, you're gonna replicate. So currently the question with Yunwin had, that state is in that CD itself, you see. So instead of that, you're gonna put that, in the data.
Exactly. So instead of that, that is just so we just have a in-memory cache of that state that's in etcd, right? And
in-memory database kind of thing. Basically.
Yeah, in-memory database kind of thing. I know you guys use Ignite, so you could even consider just having a JDBC connection straight to Ignite if you want.
Well, we are exploring Ignite, yeah.
But right now, in almost all of our use cases, people don't use a database of an SQL database, so we just use an in-memory cache of that state using something like H2.
Yeah, and just a quick question, the quick comment on here as well. The reason I'm trying to clarify this synchronization with the etcd with the DCM database is everything, even if in memory DB, everything you need to consistently write to it. Some locking mechanism has to be applied. That could affect your performance when you're reading it from DCM to get the resolver down. So that's something I'm not sure how you guys have another logic to take care of this, avoid this kind of intensively locking to the table to make the read more faster or some other thing, some other mechanism you guys have.
This is a good question. So right now the database has hardly been a bottleneck. Sorry, I'm going to walk while I just let my cat out. She's screaming. But yeah, so right now the database end has not been a problem for us, and we expect to run into these issues later. Right now, we are translating into sort of changing this into an incremental computation engine called ddlog. where we don't anticipate that these problems will be an issue, but we'll have to get there to find out. So to your answer, we still haven't hit the scales that would bring us those issues. Even at 10,000 node scales, that has not been an issue.
Yeah, that's probably the case. Like in the database, the larger table you have, the more probably, I mean, the longer it's running, it's more problematic. You probably introduced, you probably have like reindexing, all kind of stuff. Yeah,
exactly. So we need to, so the thing with the, like the reason I mentioned ddlog, this incremental engine, is that you basically introduce, like, it computes on deltas. So a normal relational database gives you tables, and you write queries and you get output tables. In ddlog, you get deltas. So you insert changes to the database and it will compute the changes made to the output tables, right? So it's the amount of work the database is doing per update is proportional to the size of the update, which is pretty small usually.
This is very interesting. This is Nikita, are you right there? Nikita? Hello. Nikita, are you there?
They're muted.
You're in mute, actually, because the reason is Nikita, actually, to give you a background, he's the guy he's the CTO of GridGain. They built out Ignite, actually.
Oh, I see.
So I wanted to, so he's on mute, looks like, but I think this is kind of very interesting though, because the ddlog thing has been, I've been kind of looking into as well. Maybe we can have a separate session to kind of understand more, because I know ddlog has been used very extensively.
I'm actually here. I'm here. I'm listening.
Yeah. So any comment from your side? This sounds very interesting to me. This whole incremental update in the database and all that. They're using ddlog and all that. Have you folks looked into that, Nikita?
Well, this is the area we can take another half a day of discussing. We're constantly looking at optimizing SQL in many different ways. But again, our use case is somewhat. Our typical use case is somewhat different. If you guys find with the 10,000 node performance already, then I think the problem is sort of a muted. Because I think if you don't have any hiccups on the 10,000 nodes, whatever database, whatever SQL engine you use, that's, I would say, good enough for like a majority of use cases. Maybe outside of some Google-like scales. So I do have a sense that, as Lalit mentioned, that SQL is not a bottleneck here.
Yeah, it's more of like not having native incremental, like sort of incremental computation that's an issue for us. There are actually
when you say incremental computation, what do you mean by computation?
Incrementally updated materialized views, and basically knowing what changed when. So the model is I do an insert and I get a callback saying these were the changes to different output tables.
Yeah, but we've done very similar work with not replacing, but basically I think with replacing it's a D with Ignite, and we've done actually these deltas already. So you might as well look at it. But again, my point is that just in the interest of kind of inefficiency, if you don't have the performance problem on that scale, then I think it's something that is
don't do it. Yeah, exactly.
Yeah, later.
Yeah. The getting deltas is actually, so this is partly what I'm looking at with Athinagoras this summer and going forward, is like, if you know the exact deltas, you can actually do certain kinds of scheduling decisions even more efficiently, like global decision making. You can do that. The deltas will tell you what subset of the state to pull in from the database, and you can actually do fairly. This is an idea we're exploring.
This is very important though, because when you're dealing with at the scale at that scale, SDN controller, we're using actually Ignite to build our next generation SDN controller. So same issue, SDN controller, you need to know each and every networking node, going up and down and all that. So the incremental update becomes a real, important and kind of a bottleneck as well. So
we should definitely deltas are not usually deltas are not usually part of any SQL engine. They're just not part of SQL algebra.
Yeah.
It's a very extraneous,
exactly.
and it's a very awkward to add this because it's like
so what we had to do with ddlog is like, because I really want to stick to SQL, so I don't have to rewrite DCM. Me and a colleague, we added like an SQL front end to talk to ddlog. And it's funny you mentioned SDN controllers, because the first use case that my colleagues applied ddlog to was network controllers.
Yeah,
so I think we should definitely set up some follow-ups on this.
Yeah, we'll be very interested in that actually. Sounding that you following ddlog, this sounds very interesting actually.
Okay, I haven't been following that.
Yeah,
I will take a look. Something interesting.
Okay. Okay. So just to like wrap up, this is my last slide for now. Like I said, so this is the state management distinction, right? Custom data structures versus, a relational view of the same state. And then instead of reasoning about one pod, one node at a time, in the vanilla scheduler, you basically end up with multi-pod, multi-node, reasoning at a time, right? Like the query doesn't really care how many, you write the queries in a way that you don't care how many things are in each of them, pretty much. And instead of writing all your policies as these very fragile filter score heuristics, you basically write them as constraints in a fully declarative way, right? You write, hard and soft constraints. You can turn a hard constraint into a soft constraint by just changing one clause with some, restrictions pretty much. But yeah, you basically you basically specify what you want the cluster management logic to look like, and we'll take care of, all the nitty-gritties of dealing with the constraint solver for you. So I'll stop here. This is the overview. The tool is open source. It's actively maintained. Okay, these things I think we can, this might be interest of, this one part I'll also mention. So here's one split that we discussed, right? Like how do you split functionality between the database and the solver? So the idea is to basically use the database for its strength, right? You filter as much as you can as early as possible. Like for example, if there are nodes that are unavailable, have no capacity, don't even bother the solver with it, filter it out in the database. If you already know that you prefer some kinds of nodes over others, sure, have a table that says, like some kind of priority ranking or some kind of score, like do all of that early on if you want to. One very good thing you can do with the database is to compute all kinds of expensive aggregates. Like I mentioned, the spare capacity per node is one example, but also like, mappings of pods to nodes or pods to pods that are mutually affine or anti-affine. You can compute all of that in the database quite efficiently. And then on the solver side, you basically just evaluate your constraints, right? This itself also has its own query evaluation to do, but we basically do that on our end. But that's pretty much it. Yeah, I'll take any questions if you have it. There's more details in the paper, which if you're interested, you can go over. The code is open source. We're actively working on it, and we're trying to get adoption on it. So if you're building any kind of new scheduler, do consider a DCM. It'll help you get started much faster.
Thank you, Lennis. Thank you. I guess, yeah, we don't have enough time to go through all details, but we probably should have time to answer a couple of questions if you guys have.
Anybody questions?
Thanks. Thanks, Light. I think it's a really good presentation and a really good effort what you've done there. Thanks a lot. I have one question. What's the bootstrapping like time and effort? Because if I understood it correctly, you keep everything in memory. So if let's say we want to change the scheduler, like on the one scheduler fails and it needs to go on the other node. So I would need to kind of restart everything, right? Because I lose all the in-memory information. So can you comment on that a little bit?
This has not been an issue in my testing so far. Again, it depends on the scales you're targeting, obviously, right? But like the way we wrote the Kubernetes scheduler, it's the same as how the vanilla scheduler works. It's soft state, right? So when you bring it up, you basically, the moment you register to the informers, you basically get a set of, like you basically get the current state. Writing that to the database has been, that's hardly been a bottleneck for us, right? Yeah, it won't be that much worse than what
but Stefan, that would be more of function of a database though, replication, because they're using an embedded in-memory database. So if you're not that node where the database is goes down, so you can have a failover kind of strategy at the database level.
Yeah.
Yeah, of course. No, I wasn't sure, what's maintaining the state, but if you're kind of using informers and if you're using all the Kubernetes, then it's all the same, right? You just use
the same.
database for
Exactly.
local processing. Yeah. Makes sense.
It's literally like a cache, like that database
It's
does not even exist outside the
Yeah.
memory of the scheduler, right? Like it's just it's an embedded database I was using.
So just another thing, these guys, they do a lot of caching, the scheduler, the Kubernetes default scheduler. So they have their caching, they read from etcd.
Yeah.
But in your case, essentially you're saying or your Java code, for example, the generated Java code goes to this in-memory database to do whatever it needs to do. Basically.
Exactly. Yeah.
There are no overheads of that, or that benefits or any. Well, benefits?
I mean, I'm not a big fan of the database we've been using thus far. It's called H2. It's like even its optimizer is pretty crappy, if you ask me, right? But it's been good enough so far. But it's one of the reasons like we really want to migrate to DDlog because it can do incremental processing and we know it's much faster. So there are some silly overheads with H2, which like I'm not a fan of, but like it's not been a bottleneck.
You're still gonna put the DDlog in front of H2 though, isn't it?
I'm going to try to avoid H2 altogether, basically, right? Like I'm going to make a DDlog program look like a in-memory database, basically.
Oh, so you're going to build a new in-memory structure, basically. That's what you're saying?
Exactly.
Oh.
Wow.
Yeah. Okay. So it'll basically, so we already actually have it. So if you look at the DDlog repository, you'll see an SQL folder, and like a colleague of mine and I wrote that. So it basically takes your, maybe I wonder if I should show you some code. So basically the Kubernetes scheduler I had to write has a schema, right? It has a base set of tables. It has a set of views. You basically give that same schema to this DDlog with SQL front end that we have, and it will generate materialized views for all those tables. And it'll basically translate all of that into data log. It will set up that in-memory engine. You do writes into it. Again, it looks like a SQL database. You do writes into it and it'll output, like it'll basically update materialized views that you can do select star or point queries to. And we also have deltas coming out of it. That's basically what we are building. Yeah. So it's basically a much more, it'll hopefully be a much more efficient alternative to H2. And you don't have to worry about writing your own, like setting up your own indexes and things like that. It'll take care of it for you. DDlog will.
So you're building a brand new database structure, basically in-memory database structure based on DDlog and all that kind of.
Yeah, sort of.
Yeah, that's interesting.
Yeah. But yeah, you can use this with anything that talks over.
But you can always, let's say, if you want to use Ignite, you can put DDlog in front of, but there will be some custom work to do that. So I can put DDlog. So that will enable the incremental functionality within Ignite for me, basically.
Yeah. So Ignite, like, keep in mind, already has something like, so as Nikita mentioned, I was looking at their documentation as well. I think, yeah, Nikita, you should probably clarify on this. But again, as he mentioned, like, deltas are really not specified under SQL, right? Like you have to go out of band for it. So there are some limitations, but I think DDlog's strength is that it can do this for even recursive queries if it wanted to. So that's why it's very useful for SDN controllers. Like it's the set of queries that it can incrementally compute is much broader, I would imagine.
Okay.
Yeah. Any other questions? Yeah.
Yeah, I guess we.
Yeah, we have 10 more minutes.
10 more minutes.
Yeah. Okay.
Thank you very much. Thank you, Lenny.
Yeah.
I guess Deepak, Nguyen, and me, and we can probably have some follow-up afterwards to discuss more details.
We should.
Yeah.
There's a lot of things to talk. I think this looks very interesting. Because the reason I say it's very interesting to me, because we tried doing the same thing in Firmament. The programming model, when you define your part affinity, anti-affinity logic, it becomes, you need to be a real hardcore graph programmer, basically, you see, which is not, the regular programmer is not a graph, the data graph programmer, you see. It becomes very complex, the programming model. Here, everybody is familiar with SQL. You define your SQL and the database does a group by and everything for you, and you're done with it, basically.
I can show, like, if you have just 1 second, I can quickly show you how tiny the like affinity, anti-affinity rules are. Just give me 1 quick second.
In fact, we ended up doing sequentially. because we didn't know how to do it in Graph, basically.
Yeah, I remember you mentioning that.
Yeah.
So do you see my screen?
Yeah, we see that's how.
Yeah.
Oh, yeah, now we can see it.
So this is literally all I had to do for specifying affinities and the affinity constraint in Kubernetes.
Is this a pod affinity or pod node?
Interpod affinity.
Interpod
Yeah.
affinity. Okay.
There's also anti-affinity, but it literally says, look at the set of pods to assign. If it has affinity requirements configured, there are two things. There's anti-affinity between pending pods, and there's anti-affinity to scheduled pods. So this is, affinity to running pods. This is affinity to currently running pods. That's it.
Nice.
That's literally it.
This is very good. This is very good.
So please have a look. There's a tutorial, but I'm happy to follow up on these things.
Thank you. We'll definitely look into more detail on either the paper or the GitHub project. Thank you.
Okay.
Annie Rupal, I think next is yours.
Thanks, Lalit. Thank you. How do you say your name? Your college.
Yeah.
Thank
You're
you.
more than welcome. Thank you.
Thank you.
Thank you.
Thanks for having us. Yeah.
Hey, Rupal, do you want to go over, or do you want me to go over all these events?
Sure.
I'm happy to.
You can start in case
Okay.
there's anything I'll pitch in between.
Then you can add to it. Okay. So
Guys, I will need to drop off. This is Nikita. I will need to drop off at about 9 o'clock. So I'm apologize ahead of it.
Okay. Thanks.
Okay.
Nikita.
Thank you. Thank you,
Okay.
Nikita.
Thanks, Nikita. I think I have received your confirmation already, so we'll follow up on that about the speaking session or email. I
okay.
think it just dropped off. So Annie, you can continue.
Okay, so all right. So for the upcoming, few months, we're gonna have a lot of events, like because obviously for Q1, Q2, because of the pandemic, so we're kind of limited in our outreach activity. But for Q3, Q4, a lot of physical events are happening, and we want to make sure that we're taking advantage of these events to help promote Centaurus and recruit more partners. So there are 4 events that are happening. I'd like to go through with you. Number 1 event, I mentioned this previously. We are actually, Click to Cloud is sponsoring this, we'll call it the meetup. It's actually a little mini conference targeting 500 plus developers in India. And it's gonna be August, in US time, it's August 13, 9 p.m. And it's India time would be August 14. Oh yeah, that's great. Yeah, you show stuff on screen. That's perfect. And so if you guys are, any of you guys, a lot of you guys are speaking, thank you very much. And if anybody who's not speaking would like to participate in this event, just check it out. Please let me and Rupal know, and we will send you down in information. So we have, thanks to Click to Cloud again, and they have done tremendous job on, setting our website, and then we're gonna start promoting it. And then it looks like we're gonna have a, Alibaba cloud speaker. Last I heard, they're gonna have a Microsoft speaker maybe. And then the Ministry of Education India might come as well. And then also the CEO of SoftBank. So Click to Cloud has a lot of outreach. So they are inviting a ton of people come in, and I think this is going to be great. Initially, we're just going to do a meetup, but it turns out to be, this is almost like a virtual event. So this is awesome. So thanks again to Click to Cloud, and thank you speakers, who are participating. And originally we had it scheduled in July, but we figure it's best to push it out. So now is August 13, US time, 9 p.m. And so that's it. So next event is OSS Summit. This is Linux Foundation. If you can Google it, Shani, or whoever's sharing the screen, if you can show that, it would be great. If not, that's fine too. So Linux Foundation generally has like 3 OSS, open source summit event every year, US, Europe, and China. And this year, they combined the European one with the US one due to the pandemic. So this is happening September 27th through September 30, and it's going to be based in Seattle. And so so we are lucky, you know, we actually we got a platinum booth. So what happens, you know, Huawei purchased a platinum sponsorship, but they can't send their people out to US to attend the event, so they gave it to FutureWay. So we have the whole entire platinum booth, which is a pretty good size booth. So and also we're gonna have 1 hour tutorial. So Rupa and Dr. Sean will be speaking that about Centaurus at that 1 hour tutorial. And if you are going to OSS Summit, please check that out. And then at the booth, we're going to show Centaurus project details. And then also, you know, start working with prospective partners. And hopefully we'll get more partners and developers to join our project. So that's OSS Summit. And after that, there's a KubeCon US event in LA, October 12th. October 13 to 15. And FutureWay has a silver sponsorship. And so we are going to also showcase, you know, KubeEdge, you know, some of the Kubernetes, you know, CNC projects that FutureWay worked on. In addition, we'll also show Centaurus because, you know, the CNCF audience, right, community would be also our target. And also whatever, you know, Centaurus works with Kubernetes, so it works very well. So this conference would work really well for us to promote Centaurus. And so that's that. And just before the KubeCon US, October 11th, October 12th, in case you're not, you know, aware, there's also Linux Foundation Networking and Edge Summit happening in the same event. So these two events, LF Networking and Edge and KubeCon US, they are happening back to back at the same venue in LA. So, you know, unless there's a problem with the pandemic situation, I would expect a ton of attendees because, you know, a lot of people, you know, open source people, they love to, you know, get together, see each other. There's a pent up demand. So yeah, hopefully, if you guys will be there, maybe, you know, let me know. I can host a dinner or something. We can get together, finally meet in person. That would be really fun. Oh, going back to OSS Summit, just want to let you know, because of Huawei sponsorship, we have a one day conference room. So we're planning to do a CIO roundtable using our conference room. So half day for that conference room, and this is, you know, FutureWay's private room we have because of the platinum sponsorship. So in the morning, we are going to do a roundtable CIO. We're gonna invite, you know, whoever wants to come. If anybody C-level who wants to come, let me know. I like to invite them, and then I can also give that person a conference pass to, you know, attend. So, you know, the C-levels, we're going to talk about the future of 5G, edge, AI, and cloud computing. And we're going to do that roundtable actually on the 29th, September 29th. No, 29th, yes. And then in the morning, in the afternoon, we're going to do a Centaurus deep dive. So Dr. Sean's 1 hour round tutorial is at 11:30, something like that, right after the keynote. And he's going to announce this deep dive on September 29th. So September 29th, our private conference. In the morning, we're going to have a CIO roundtable. And in the afternoon, we're going to have a deep dive session. So any of you guys want to attend any of this, please let me know. And I can, you know, and then I can give you the information to attend that event. So yeah, so coming up, we have 4 opportunities to meet with prospective partners, meet with developers. So hopefully we'll have a lot more momentum, get a lot more resources to help with our project. That's it. Rupa, do you have anything to add?
No, I think, Annie, you covered most of the area.
Okay, great. Any question? Yes, Stefan, do you guys have plan to come to US for for any of these US events?
That is a good question. So far,
No. Is there any still travel limit? I haven't really followed that.
Yeah, that's also something that we're kind of also worried about, and we were on the fence, and now we're kind of leaning more towards like no. And we also submitted actually a paper or a talk for the OSS, and it's currently in the what's it called, on the waiting list. But even if it gets accepted, kind of we are planning to do virtual presentation there. So yeah, most likely we will not be coming.
Yeah, Stefan, if you are coming, let me know. I might be able to get you a conference pass.
Oh,
Yeah,
that's
so-
very good. Okay,
So let me
thanks.
know. Yeah.
Thanks a lot for that. Thank you very much. Yeah, that sounds really cool. Thank you.
Okay. Okay, great. So that's all I have. Thank you very much.
Thank you, Annie.
Thanks.
Any
Annie.
other questions? Okay. If not, Deepak, I guess we do not have time today for your agenda
That's
item.
fine. That's
And
fine.
also, we do not have enough TSC member today to vote.
Yeah.
Because
That was
Nikita
also
just
my
dropped.
concern. Yeah.
Yeah, because Nikita also dropped. So
Yes.
I guess we probably leave to your.
That's fine. That's fine.
Yeah.
So we need 5 out of 7, isn't it? 5?
Four
out of 7?
four.
4 out of 7. Okay. But let's wait for next week, next month. Yeah. But
Hey,
yeah,
Deepak,
great.
I just have one quick question. Last time we discussed about Cube Edge integration with Centaurus. So is there any progress on that area?
Regarding what in open source or
The Cube Edge integration with Centaurus itself, like adding the edge.
Oh yeah. So that's been going on. Yeah, that work is going on actually. Yeah. So we have a project that we call, I forgot the Fortrain. I forgot the name. In any case, yeah. So we are doing a lot of major work actually in that. And
I
one of
see.
the TSC meeting couple of months ago, we presented the whole design and all that. How we taking forking Cube Edge and extending the whole federation and the east-west the communication and all that kind of stuff. We're doing a lot of work.
Oh, yeah, I remember that. And after that, I think we discussed about some of the designing spec, that how we are going to.
Yeah, they're all
integrate
open source. They're all there in the on the web, on the GitHub.
Yeah, well, I can share the URL with the Rupo. I wanted to share
thing.
screen, but due to some permission issues, my Zoom now cannot share the screen. I can send it.
Probably you can share the document. Yeah, I'll check with team,
Yeah.
because I remember last time Dr. Shong asked us to like pick up some of the modules for Cube Edge and see how we can integrate those. If team have already started, probably we can assign our current team along with them to see how that integration is happening.
For Deepak, you're talking about the
development part.
Yeah, the Forex project, right?
Yeah. Forex.
I'm sharing the URL in the chat window in Rupo.
Sure.
Because
Mengni already put that.
Okay, yes. Because this morning I just switched to a new laptop. I forgot to set the Zoom, give the Zoom permission to share screen. So I cannot share screen.
Yeah, there's a lot of work being done actually. So we have our weekly meetings, weekly team SIG meetings. Anybody is publicly available. Anybody can join. I know Rupal, you joined initially, but then you didn't come after that.
Earlier it was jet lag. So
but yeah, it's a US time as well. So if you're in India, 3 p.m. here is not really convenient.
Yeah. So, well, I'll be back next week, so I'll continue joining that.
Yeah. You're welcome to join. You're already there in the list anyway.
Yeah. Thanks, Deepak. Thanks, Shawnee.
And no problem. And also, Deepak, Annie, for the roundtable event in the Code Fest, probably we need to exchange some email to discuss what exact topics we want to cover in that chat and in the panel discussion before the event. Yeah.
Right. So it's going to be the roundtable. This is the OSS event, not the.
Oh, no, so sorry. I mean the panel discussion. The panel discussion.
The panel discussion.
Oh no, the one on the 13th.
Actually,
it's the August 13th one.
For that.
Yeah. Okay.
We'd better set up some think up on some specific topics that we want to discuss in the panel discussion.
Yeah.
Actually, I'll set up some of the questions and we'll sync up before probably next week between Deepak, Annie, and Shawnee.
Oh, that would be very helpful.
Yeah, we should do it because we don't want to go there cold. And
we don't want to sit there at the final.
That's
Let's
fine.
have an offline, another meeting to talk about. So Rupo, so exactly what's the sequence? Is Dr. Sean is 20 minutes, right? And then after
Yeah.
that,
Prashant is 15 minute, then Dr. Shong is 20 minutes, and then your the panel discussion between three of you will be almost 20 minutes along with Q&A. And there will be like 3 sessions, the back-to-back sessions that with Nikita, Stephen, and
So,
the
I,
other
I would
speakers.
I would suggest, so Xiaoning can talk about, we don't just jump into panel, because I still like Xiaoning's talk about TSC, because it will be good for people to know, we have a TSC. So maybe Xiaoning can spend 5 minutes on TSC, right? Operation, like we have, like monthly call, and then this, and then show people where, like if they want to come, these are the, dial in, and then this is where they can find minutes. So it will be good for Xiaoning to talk 5 minutes, and Deepa maybe talk another like 15 minutes or
Sure,
10
actually,
minutes on the
after
technical deep.
Dr. Shong, there will be one more speaker from Microsoft. He's a like research scientist at Microsoft.
Right.
And then one more from Alibaba as well. She's like vice president of Alibaba Cloud. So 4 keynote session, 1 panel discussion, and 3 sessions will be the in that particular agenda of 40
Right.
minutes.
So what I'm saying is, instead of making a panel, maybe we can have 3 short presentations, because we really want Xiaoning to present, right?
Sure.
We don't want to make it like just a Q&A. I mean, it's more of a presentation.
I'm fine with either option. What do you guys think?
No, I think Annie is right, actually. I think the presentation of Xiaoning doing the TSC presentation and I'm doing the deep, I think that will be much more powerful than doing.
Powerful, right.
That'd be fine.
So,
I'm fine with that.
Yeah.
yeah, and then I can do the Q&A in the end. Like if I'll have to do a 5-minute Q&A for you guys. That's it.
Yeah.
And you can give me questions ahead of time. And then, so how does that sound? But in total, we have 20 minutes, right? Basically, what you're saying, Rupal, right?
Yeah.
So
that sounds good to me. I can prepare
Right.
talk about the TSC, how it works, and all the
Right.
information, and how people can participate.
Yeah, exactly. And then so you do that because we want to show this is really a formal project. We do things according to the open source principles. It's open principles, so it's very important we do that.
So you're suggesting that we should not do panel discussion then?
No panel. So I would suggest, you don't have to change your agenda, but we'll just present this way. So Rupa, you don't have to change your agenda, right?
Sure,
We can
sure.
present this
Okay.
way. I can host this for 20 minutes. So I can say, Shani, you can, I'll introduce him, and then he can present TSC operation, overview, like 5 minutes. And Deepak can have another 10 minutes to do a deep dive, Centaurus deep dive, a little bit more, 10, and then I will leave 5 minutes to just.
I like this better, yeah.
That's good.
Yeah.
That's okay. Yeah.
That's good. I'll update. I'll not change anything on the website. I mean, we'll keep in the same way, but the same that you mentioned, Annie, will follow that.
Yeah, you don't have to change
Yeah.
the website. We'll just organize this 20 minutes ourselves, and I will host it. How's that?
Perfect. Sounds good.
Okay, thanks.
In this case, then we do not need the alignment.
Yeah, we don't need that.
We don't need that.
Yeah.
I will just prepare some slides talk about introducing a TSC and the 4 SIGs we have, our Fox area, and how it works, how the.
I think that's important because we want people to know the 4, 6, and then so they know where to sign up.
Yeah.
Right. And then Deepa, you can just go over like.
No, I like this. This is much better. Yeah, but then it kind of dilutes, although it might be a duplication as well. So I thought my impression was that we want to do those 3 presentations and the panel discussion as well.
No.
What Annie is suggesting is just how we do the panel discussion. There's still panel discussion, but we internally we spend into
sequence to it.
Yeah, because so what happened was our time slot got taken by Microsoft and Alibaba now.
I'm so sorry, Annie, for that. I mean, we still have 15 minutes at the end. We'll try to cover, use that 15 minutes.
No worries, no worries. We understand.
No, I think Annie, this what you described is much better. I think so.
Okay, let's just do that. So 20 minutes. So Shani, you prepare 5 minutes. Deepa, you can prepare 10 minutes material, and 5 minutes I'll do a Q&A and wrap up our.
Deepak, what's the part where you talk about?
I'm just gonna cover all these 4 SIGs. Like what it just like a 2 or 3 slides for each SIG. What have we done for RTOS, multi-tenancy and all that. That's your stuff basically. So,
oh, yeah, no problem. I will
yeah.
just give a very brief overview of the 4 SIG.
Yeah, you just, exactly.
Then you can talk more details about the project.
Yeah, just like 2 or 3 slides for each project, those 4 SIG.
Yeah, maybe Deepak, you probably can focus more on projects. I can
exactly. That's exactly.
TSC and SIG.
Yeah, exactly. That's what I'm saying. So that's what Annie is saying that as well. That you just focus on the TSC thing. What do we do on TSC, and then I'll focus on the projects basically.
Yeah.
And then I'll have just come up with a couple questions. And if you guys have any question you want me to ask, just send them to me. Otherwise, I will come up with a couple questions and send them to you, so you know the answer. You can get the answers ahead of time.
That's good.
Okay.
Okay, thanks Lalit, and thanks. I think there's a lot of interest in your work. This sounds very interesting, because I can tell you that because this whole declarative thing, we looked at it from firmament standpoint as well, but there were some issues in the whole complexity of programming model. So I know Xiaoning has been looking at it as well. He's very interested.
Yeah, in ByteDance, we are building a brand new scheduler for the ISVM scheduling. We are building it following the traditional way, the heuristic approach. But my team also has the responsibility to look into innovative research in this area. So I'm very interested in.
So Lalit, so Xiaoning used to work with us. He works at TikTok now.
Okay. nice. I think we should follow up on this. Like your these cases where you have to build the same thing again with slightly different shape is basically what this.
We'll do a common meeting, because this is a common topic for all of for us as well. Actually, so if we can do another session. And I know
I'd also like to be part of this.
I know for sure. I know
Stefan.
Yeah, we are building this for the edge as well. So.
Oh, perfect.
Definitely,
I don't know.
definitely.
Next week is good for me, but Deepak, you send out an email.
I'll work with Xiaoning and then Stefan and make something happen.
Sounds good.
Great.
Okay,
I'm in a different time zone in Europe, so that might be a little bit tricky, but I'll really try to be as flexible as possible.
This morning time works for me, so we can.
Yeah, so Stefan has done a lot of scheduling work too. So
Oh, great. So I'm speaking to the right audience.
So Stefan is a researcher, and he's a postdoc at TU Vienna, University of Vienna.
Okay, nice. Hey.
Yeah. So anyway, good.
Yeah. I'm looking forward to this follow-up meeting for sure.
Great. Thanks a lot. Thanks for inviting us.
Bye-bye.
Thank you, everybody. Thank you for joining.
Bye-bye.
Thank you. Bye-bye.